In the last video, some people debated that the thing I called VRM was not actually VRM, but they were inductors or coils because they have coiled wires or chokes. I am very appreciated that everyone provided me with information and I learned a lot by doing extra researches, but the VRM consists of capacitors, MOSFETs, and inductors, so I think I was still technically right. Many people mentioned that the inductors didn't generate heat, so they didn't need to be cooled. The only parts of the VRM which required thermal pads were the MOSFETs. But with the heatsink and fans, all the heat travels from the hot components into the heatsink and get blasted on the PCB. We can imagine it is similar to a hair dryer blowing hot air all over the PCB surface. What I am saying is, the inductor don't get hot by themselves, but by the heat from other components. And later in the video, I will show you having a blower style cooler, which this card has, is quite a terrible choice for a single fan card. I am unable to show the top of the PCB of this card because it is completely covered by the plastic shroud, but we can still see the back of the PCB through some holes of the backplate. I was running the card as stock. With my thermal camera, you can see around the GPU chip, the temperature was around 75 degrees. If you look at the petals of the flowers at the front of the card, the temperature was around 66 degrees, and this is already further away from the chip. This is the back of the PCB, so the temperature in the front would be higher with all the hot air circulating around. In the last video, I tested the card on a test bench, so the air suction was always cool. But in the worst case, we put a card in a case with limited airflow because this is a small card so it fits. And the fan may suck back the hot air generated by the card itself, so the temperature of the PCB could get even higher. It's up to you to trust Zephyr, but after playing around with the heatsink, I'm gonna play it safe for my card, because I think in mini PC, any cooling solution is welcomed. I recently had a video about a Corsair SF1000 PSU, so I decided to put the new power supply and the GPU into the Mi6 case. This is still my most expensive case I ever owned. This case is also a good example to test this GPU's temperature. It does not have any hole in the front, and the top panel is not really opened up, so any hot air pushed to the front of the card would be choked inside the case. There's a 92mm intake fan at the bottom, but I would keep it off for testing. Upon firing up a game, I noticed that my CPU was cooked at 91 degrees, and I think it was due to the IS55 cooler, so I swapped it out for the IS67 XT. It has a taller heatsink, so it can suck more cool air from outside and help reduce hot air getting circulated back to the fan. This cooler also has short AMD mounting brackets, so the heatsink can be installed overhanging the RAM or the motherboard I/O, which provides us with an optimized position for the cooler's heat pipes. The game I used for testing is Black Myth Wukong at 1440p. You can see the new cooler keeping my Ryzen 9 5900X under 90 degrees. The RTX 4070 was running as stock, and the hotspot temperature was very high. At some point, the hotspot reached 99 degrees, while the overall temperature was around 81 degrees. This made the fan run at maximum speed and was very loud. The clock speed, as you can see, was all over the place. With undervolting, 2750 MHz at 975 mV, the temperature of the card was around 73 degrees and the hotspot dropped to around 86 degrees. Compared to having the card on my open air test bench, the hotspot temperature was 6 degrees higher. As you can see, in a sandwich layout case which supports single fan GPU, this card is pretty toasty without undervolting. So make sure to use software to adjust the voltage to reduce the noise and temperature. In the last video, I said I would open the card and add some thermal pads. Let's do it. There are only 6 screws which we need to remove to disassemble the GPU. There was a sticker on one screw and it was so damn difficult to remove. I had to unscrew it to scrape off the residue. Once the 6 screws are out, carefully split the PCB from the heatsink. Luckily for me, it was not too sticky at all, and thanks to that, none of the stock thermal pads of the card got damaged. Here you can see the thermal paste which were used on the die. To unplug the fan, the trick was using a flathead screwdriver and lift the fan header from both sides. We can remove the backplate by removing the 6 screws attaching to the PCB. While the shroud of the card is made of plastic, I did not notice that the backplate is made of metal. There you have it. The Zephyr RTX 4070 ITX was easily and completely disassembled. A few years ago, I also opened the MSI RTX 3060 Ti Aero ITX, and I think it is due for some maintenance, so I opened the card again. The paste I used was Thermal Grizzly Cryonaut, and it is still wet as you can see. I said in the last video that the PCBs and heatsinks of these two are identical, and I could install the backplate of the 3060 Ti to the 4070. While waiting for the new thermal paste and pad to arrive, let's replace the heatsink. For testing, I used the RTX MX4 thermal paste on the card. After that, we can install the heatsink to the card by using the Zephyr 4070 screws. The MSI heatsink fits perfectly on the 4070, so I call this the Zephyr MSI RTX 4070 Aero ITX. I want to do this because I expect better temperature due to its open shroud, unlike the stock blow style cooler. Sure, it was better. How better? The temperature of the card inside the case was as similar as the 4070 with the stock Zephyr cooler on my open air test bench. At stock setting, you can see the temperature of the GPU was maxed out at 72 degrees, while clock speed ranged from 2700 to 2745 MHz. I am not sure if replacing the thermal paste helped, but the hotspot temp was so good, it peaked at 86 degrees. With undervolting, the temperature was topped at 66 degrees, while the hotspot was maxed out at only 78 degrees. So, having a better shroud improves the overall temperature, while replacing thermal paste may help with the hotspot temperature of the card. While the game is running, I could feel the airflow and the heat rising to the top panel of the GPU side. This clearly keeps the hot air from getting trapped inside the case. I ordered both thermal pad and thermal putty to try them out. Thermal pad is 2mm thick and it is from Palit, while the 20g thermal putty is from Upsiren, and people have been recommending this to me for a while. The stock thermal pads of the 3060 Ti were fine, but the ones I replaced became dry and crusty. So I moved the VRAM and the MOSFET pads from the 4070 to the 3060 Ti. Of course I could have used the putty, but I only bought 20 grams, and throwing away the perfectly fine pads is wasteful. The two cards PCB are identical, so their pad thickness should be the same. I used the 2mm Palit thermal pad on the inductors of both cards. For this position, you don't have to worry about the thickness, because the fins of the heatsink will cut into the pad when we press it down. I use putty at work, and now I go home, I still have to work with putty. 20 grams of this is not much, but according to other users, thermal putty can be reusable unlike traditional thermal pads, and we don't have to worry about the thickness. So if this thing works, I will consider completely switch to it in the future. My first impression was this thing is very squishy and soft. It is also not sticky like thermal paste, so applying was very easy. This was my first time to apply, so I just caked the MOSFETs and VRAM. I will reapply later in the video, as I think doing this way does not create good contact and it may have air gap. With the incorrect method of applying, I still used around 1/4 of the package. For the GPU die, I used Honeywell PTM7950 as this is recommended to avoid pump out effect, especially with direct die cooling. I bought this from Chom on Amazon, but you can buy this product from LTT store or Mod DIY. People suggest putting this in the freezer for easy application, but from my experience, all you need is a good tweezer. You might notice I struggle a bit with peeling the film. The tip is to peel it slowly while pressing the already peeled paste onto the die. This helps prevent the unpeeled paste from tearing. I did much better on the second time with the 3060 Ti. It looks perfect. Now onto the mess. At first, both cards did not boot. For the 3060 Ti, I think I screwed it in a bit too much. So after I unscrewed a bit and tried splitting the heatsink from the PCB to reduce the pressure, it worked. I tried the same with the 4070, it did not work. I had to trace back what went wrong, so I opened the 4070 to remove the thermal pad from the inductor, and the shit booted. I did not install the two screws behind the MOSFET side, so I thought maybe the pressure from the heatsink and the thermal pad caused short circuit, which was not really reasonable, but I was panicked. I opened the card, replaced thermal pad with thermal putty on the inductor because putty is much softer. Install the heatsink back, no signal. I opened the card, removed the putty, removed the PTM7950 and used normal thermal paste. No signal. I knew something was shorted, so I thought maybe the metal backplate was the issue, so I removed it. No signal. I was so desperate and stressed, I opened the 3060 Ti and installed its heatsink on the 4070 without any backplate. It booted. I was relieved that I did not kill the card, so I just needed to find the cause. Without the backplate, I could see the screw holes clearer. Let's take a look at the white ring around the screw hole. The card uses spring screws, and you can see the spring of the screw spread it and touch the white ring. But this one had nothing around it, so this one is fine. For this hole, there are a few components at the white ring, which I am not sure if they are SMD capacitors. Please let me know. I suspect when I reinstalled the heatsink, the spring spread it and it touched one of these, which may cause random short circuit. There are two screw holes which have this problem. To confirm the theory, I reinstalled the OG heatsink and backplate. I paid attention this time when I screwed, and it worked. So 2 times in a row. Like I said previously, I believed I applied thermal putty incorrectly, so I opened the card one last time. I scooped out all the putty from the card. I rolled them on the table to create some sausages. Some people actually prefer rolling them into balls. I did the same for the VRMs. Finally, I reapplied a new layer of PTM7950 as well as scrape off the old one from the heatsink and laid it on the die just for good measure. PTM7950 is very expensive, so some people actually just reuse them. And for the 3rd time in a row, the card worked. I was so lucky that the shorting did not kill my card, and the spring screws did not damage these components when I screwed them in. But why the fuck are these so close to the screw hole? I might be wrong about the cause, but from my process of elimination, avoiding touching them was the only way that made my card work again. Now back to the benchmark. I ran the game for 20 minutes as stock, then I opened the hardware info 64 and noticed that I forgot to check for VRAM temperature before replacing with Putty. So I didn't have the data to know if the temperature of VRAM was better or worse. I apologize for that. For the hotspot temperature, it hovered around 91 degrees and peaked at 96 degrees instead of 99 or 100. Some improvement, but it is still very toasty there. The VRAM temperature was around 92 degrees and peaked at 96 degrees. Again, if you have the card and have not opened it yet, please check and let us know the stock VRAM temp. The overall GPU temperature was at 76 or 77 degrees instead of being at 80 or 81 degrees with the stock thermal paste. Side note, I checked my 3090, which was a bigger card, already undervolted and not inside any case. Its VRAM temp was around 84 and max at 86 degrees. So for a tinier card, that temperature could be okay as long as it is under 105 degrees and no throttle. I know they are different cards and one has 24 gigs, but I just wanted to share. With undervolting, the max hotspot temperature was now at 84 instead of 86 or 87. Overall temperature also dropped from 72 or 73 down to 69 or 70 Celsius. You can see the pattern that with PTM7950 we reduced by 3 degrees for both average and hotspot temp of the GPU. For VRAM, the temperature hovered around 88 to 90 degrees and max at 92. In conclusion, I am so tired of messing with his card. The thought that I ruined it really took a toll on me. It was a fucking nightmare. So, should you open the card and do what I did? First, I think replacing its thermal paste with PTM7950 was worth it. It yielded some minor changes, but for long term, you don't have to worry about the pump out effect, and like I said, any improvement is welcomed. For adding pad on inductor, it is really up to you to decide to listen to me or the comment section. For me, I would if I stick with using the stock cooler because it performs terribly. Which takes us to the last one, the cooler. Imagine still using a shitty blower style cooler on a modern GPU in 2024. Now, if you want to improve the temperature, remove the backplate. When a fan blasts the air down the PCB, the backplate is what blocks the hot air from getting out to the top. You may not need to get rid of the front shroud and fan, but compared to the MSI card, the shroud still has much more plastic covering the card. You can also try the Palit heatsink, but I am not sure if its shroud is more or less open than this one. You can even go extreme by de-shrouding and use your own fan. Anyway, from my testing in this video, the card could have been 13 degrees cooler in hotspot temperature if it has a better cooling solution. But nothing beats undervolting. It is the cheapest and easiest way to get better temp. If you open it, pay attention to the screw holes when assembling the card. This video is long enough and I did not expect it to be this messy, but for the next one, I have a very interesting ITX case from Taobao, which I think some of you may like. Thank you for watching. Bye bye.